Space. Humans have marveled at the wonders beyond since the beginning. It's probably safe to say that most people, on an average day, probably don't pay attention to what's going on up there. Yet, when we do, it's quite obvious that we are moved. I think back on the eclipse of 2017 and the world's reactions to it.
Yes, it's just that dark out here, and it's getting darker as we look. Okay, here we go. Oh, listen to the cheer. I think it says a lot. Let's listen for a moment. Okay, now we've switched over to night vision because day has turned to night here at this little moment that you're sharing with the rest of the nation.
Yeah.
What do you feel in your heart?
Man, it's incredible actually to be here like amongst all these people and for everybody to come together to see this. I think it's incredible.
I spoke to a gentleman over here who told me that, you know, in a divided nation, he'd like to bottle this moment up and keep it. How do you feel in a country where we have so many divisions that today 15,000+ people are standing here in Carbondale inside the stadium looking up and sharing a moment together?
I think it just shows us how powerful we can be when we all come together, even with everything that's going on. You got all different type of faces and people out here that came together for this moment. It is incredible. It really is.
I'm kind of giddy and sort of in awe of all of this with Mother Nature.
Yeah, man. It is like I didn't know this was possible, like especially in our lifetime to be able to see something like this. Like, it's crazy. It's incredible.
So, I'd like to know if you have a favorite planet. Ooh, let's go even further. What's your favorite moon? Not sure? Well, have I got a great option for you.
Podcast presented by SonicEmbassy.
And liftoff, episode 01, Milky Way Marvels, Europa.
So what is your favorite planet?
I like Neptune and Uranus because Neptune's blue and it's, you know, the sea's Neptune. You know, I was fascinated with water and blue and stuff like that. And then I like Uranus because it spins on its side and it still has that little ring, which I think is pretty cool.
I would have to say that Saturn is my favorite planet because of its, of course, amazing rings that surround it. I think these rings are really, really cool because they basically take what could be considered trash floating around in space, these old broken comets and asteroids, and they suck them into this ring system. And, you know, with a little bit of ice in there, it basically makes these amazing rings that orbit Saturn. And we even get to enjoy them through telescopes today, which I think is just incredible.
My favorite planet would be Earth.
Ooh, well played. Good answer. Okay, what would you guess is my favorite planet? Besides Earth, of course. Mars? That'd be a good guess. Saturn? That could be. But if you guessed Jupiter, you are a winner. I feel like Mars gets all the attention, but Jupiter has been my favorite planet in our solar system for a long, long time, which is a topic for another episode. While many of us have a favorite planet, one thing that often gets overlooked are moons. Now, even if you don't know much about any of the planetary moons in our solar system, you at least know about one. It's the most famous moon we know. It's the greatest of all the moons in our solar system.
We have pictures of you so-called mooners. Just because the pictures aren't of your faces doesn't mean we can't identify you.
Okay, no, not that moon. I'm sure you've already guessed which one I'm talking about. Look up and you can see it with your naked eyes. Yep, our moon, Earth's moon. I'm talking about a moon so great we call it the moon. Our moon is very important to us, to our planet, yet it's somewhat bland. It's sterile. Don't get me wrong, I love La Luna. But when you think about other planets' moons out there, you might just automatically think that they would be like ours, look like ours. I've pretty much always been fascinated by astronomy. Science fiction, science fantasy, And while I knew all of our planets in order from the sun for the longest time, which I'm very proud of, including Uranus, that was the obligatory Uranus joke. Okay, I know it's Uranus, all right. Get that joke out of the way. I never really paid attention to any of their moons. This new fascination of mine is fairly recent. Let me take you back. I think it was early to mid 2000s. I was at work, but with my super short attention span, I was not work. You know what? Let's call it taking a break. And something sparked my thoughts to look at some astronomy stuff. And when I think back, it was probably the Cassini-Huygens mission to Saturn that was ramping up. So it was most likely the summer of 2004.
We're excited here at NASA's Jet Propulsion Laboratory in Pasadena, California, because we're about 36 hours away from reaching Saturn. Today we'll have an overview of the Cassini-Huygens mission, a cooperation between NASA, the Italian Space Agency, and the European Space Agency.
That was Natalie Godwin from NASA's JPL in June of 2004. And there is where I fell down the rabbit hole. I discovered a website called 9planets.org. I began browsing and reading up on the planets, most likely starting with Saturn, since that's what was big at the time. They had a breakdown of each planet's major moons. Some great images of them. And I was drawn to one moon in particular. Now, there's some really, really cool looking moons out there to me, like Saturn. Saturn has some really cool looking moons, like Enceladus, with its white, icy surface with cracks and lines that reminded me of a ball of rubber bands. It's weird, I know. And don't get me wrong, Enceladus is right up there at the top in awesomeness and probably deserves its own episode. But right now, I'm talking about one moon in particular. There was also Titan, which had an atmosphere and was thought to be kind of Earth-like, which was so cool. I remember seeing Mimas or Mimas, which looks like the menacing Death Star from the Star Wars movies.
Look at him, he's heading for that small moon.
I think I can get him before he gets there. He's almost in range.
That's no moon. It's a space station.
It's too big to be a space station.
Or a giant eyeball.
Eyeball, the most blinding horror ever seen. Eyeball.
And Jupiter, protector of Earth, had some really cool looking moons too. 4 really striking ones. Now, this makes sense because Jupiter is the most awesome planet we have, right? Okay, well, I suppose that's debatable, whatever. But seriously, besides having some of the dopest sounding names, these 4 moons are really, really cool. They are Jupiter's 4 largest moons, also referred to as the Galilean moons or satellites, named after the Italian astronomer who discovered them, Galileo Galilei, in the year 1610. There was Ganymede, which is the largest moon in the solar system, which had these dark areas that kind of reminded me of Earth in some strange way, and also looked like someone dropped some white paint on it. I saw Callisto, a gorgeous moon, the second largest of the Galilean moons, which looked like it had lights inside of it. Like if you were to flatten it and unroll it like a map, it would look like a snapshot of the night sky. Callisto's probably my second favorite, most interesting looking moon in our solar system. I also saw the 3rd largest moon, Io, with its strange yet at the same time very pretty greeny, orangey, yellowy looking colors of sulfur and zit-like volcanoes. In part because of Jupiter's immense gravitational pull on Io, Io is the most volcanically active body in the solar system. It's like Io is always simmering, ready to explode. I wonder if Io is a teenage daughter. Io reminds me of something I would see when I make the mistake of looking at my face in my wife's super duper magnification mirror in the bathroom. But prettier than that. And then I saw her. the baby of the Galilean moons, about the size of Earth's moon. You know that meme of the guy who's with his girl and he's looking back at the other girl and his girl's looking at him like, hey, how could you? Or in the movie Batman from 1989, when Joker's looking at photos and...
Stop the press. Who is that? Now that girl has style. Jesus Marimba. A lovely beast like that running around could put steam in a man's strides. Hard to stay inside the lines.
That's kind of how I felt, with all those cool-looking moons, and then I see this one. I believe the images I saw were taken from the Galileo orbiter from 1998. I can't explain why I was so drawn to this heavenly body. Something seemed different, captivating. There was something smooth about her surface, yet not smooth at all. Something about her colors, a perfect blend of white with subtle hints of blue. And along with visually stunning whites and blues, there was another prominent color, these reddish-brown lines crisscrossing all over the surface like veins or like the rosy cheeks of a blushing beauty. Perhaps something about it reminded me of the fictional icy snowy planet called Hoth in the Star Wars universe, featured in the movie The Empire Strikes Back.
My lord, there are so many uncharted settlements. It could be smugglers, it could
That is the system. Set your course for the Hoth system. General Veers, prepare your men.
Whatever it was that grabbed me about Europa, I found her majestic, resplendent, awe-inspiring. She is beautiful. And why do we always refer to objects as female? That sounds like a topic for a future episode, but enough about her looks. I needed to find out more about this heavenly body. So I started to read about Europa, and that's where the real intrigue began. Imagine that. When you go beyond looks and get to know something or someone, you can gain an entirely deeper perspective and like them even more. Or not. So, here we go. Remember how I said that Europa's surface looked kind of smooth? Well, as it turns out, it is smooth. Relatively smooth. The smoothest of any known solid object in our solar system. There are no mountains, very few craters, and no valleys. And there is a really awesome reason for that. Scientists figured out that Europa's surface is mostly water ice, and there is strong evidence that underneath all that ice is a global ocean of liquid water. Are you kidding me? Awesome. Let's go back in time. 1979. Voyager 2 makes a close flyby of Europa. The intersecting linear features that are observed suggest cracks in ice over a liquid water ocean. We need more. So, enter Galileo Orbiter.
For main engine start.
Launched in 1989 aboard Space Shuttle Atlantis.
We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
And like the astronomer from whom it got its name, Galileo's mission was to explore the big boy Jupiter and its area or system for 2 years in more detail than had ever been possible at that time.
And it is my distinct pleasure to declare not only are we in orbit, but we're in a very good orbit.
The information about Europa that Galileo sent was so intriguing that the mission was extended to make a total of 12 close flybys of the icy moon. See, it's not just me. So, on September 26, 1998, NASA's Galileo spacecraft, in one of its planned 11 flybys of Europa, most likely snapped those images that stole my geeky heart. Here is Dr. Claudia Alexander, Galileo program manager, in September of 2003.
We learned just mind-changing things. Every time we went by the moon Europa, the estimates of its age began to drop dramatically. Oh, it's not 3 billion years, it's 1 billion years. And then, it's several hundred million years. The crater count seems to show that, it could be 10,000 years. It just dropped until now we're thinking that, well, maybe it's still active. Maybe there's a layer of liquid water under there that might be relatively close to the surface. Maybe there's an appropriate environment suitable for some sort of extraterrestrial life. This is just, it was science fiction. We started out, we went there in what they called an exploratory mode. We don't know anything, and we're just there to see what we can see. And what we learned was phenomenal. So it was that was the style of mission that it was, and was, definitely worth its weight in gold.
Scientists think that Europa's ocean may have twice as much water as all of the Earth's oceans combined. Europa's ocean is thought to be at least 100 kilometers or 62 miles deep and covers its entire globe. So, what makes scientists theorize that there's a liquid ocean there? Of all the conclusions one could conclude, water? Really? Isn't that too far away from the sun? Isn't everything in space too cold? Well, first, it's her smooth skin. If you notice, it seems like most moons have, a crater face. Let's be clear, you should never call another human being that. Only planets and moons. Okay, take for instance our moon. It has impact craters you can see with your naked eye, as do most, if not all, moons. But with Europa, the surface we see today is much younger than Europa itself. In fact, Europa has among the youngest surfaces in the solar system. It's as if Europa's surface has been paved over.
If you look at this image of Europa, you can see that the surface looks very different from, say, the surface of the Moon or Mercury. Those bodies are very heavily impact cratered. They've got a lot of cratering scars on them, whereas Europa, you can see, has hardly any. In fact, I'm not sure you can even make any out at this scale. Now, we use the number of impact craters on the surface of a body as a proxy for age. We assume that things like comets and meteorites that are coming into a system impact the surface on a fairly constant basis. And so if something has a lot of them, that means that it's been sitting there getting this weathering process for a very long time. Whereas if something doesn't have many craters, it's probably very young. And in the case of Europa, something has happened to erase the impact scars from the surface. And in this case, it could be tectonic features, so faults and fractures on the surface that could erase whatever's come before. It could be some kind of cryovolcanism, and it certainly could be chaos. And in fact, the average age of Europa is thought to only be about 60 million years. Now, on human timescales, that's a very long time, but in geological timescales, that's a blink of an eye. It was almost born yesterday on the surface. So Europa already has a very young surface age.
That was planetary scientist Louise Proctor in 2011. While Europa's surface is relatively smooth, it does have a lot of cracks. Europa's surface is a chaotic mix of ridges, bands, small rounded domes, and disrupted spaces that geologists call, chaos terrain. Throughout Europa's orbit around Jupiter, at times she is closer to Jupiter, other times farther away. It's thought that this causes a sort of high tide, low tide. When it's high tide, the sea beneath the ice rises higher than normal. If that's true, the constant rising and lowering of the sea pushes up the ice and therefore causes many of the cracks we've seen. Ridges may form when a crack in the surface opens and closes repeatedly. Areas of so-called chaos terrain contain blocks that have moved sideways, rotated, or tilted before being refrozen into their new locations. I'll let the experts explain it in a different way. This is Brittany Schmidt, postdoctoral fellow from the Institute for Geophysics, University of Texas, Austin in 2011.
We're excited about Europa because it represents a place that's somehow alien and yet strangely familiar. And so I'm excited to tell you about lakes on Europa. These are two images of geologic terrain taken by the Galileo spacecraft, and they show what's called chaos terrain. These are broken up regions of the surface characterized by a hummocky, brown, textured material we call matrix, and large icebergs in many cases, which you can see in both of these images. One of the motivations for this study was to try to understand why are these two features so similar and so different. On the left, you're seeing Terra Macula, and on the right, you're seeing Connemara chaos. Connemara chaos is, in fact, perhaps the archetype of chaos terrain and gives us a picture of what Europa's activity may have looked like. And it's been thought for some time that this represented the interaction of ice and water, but how that actually works out has needed more explanation. And so we went to work on trying to understand this. And so the way that we gave perspective to the problem of chaos formation on Europa was to look at environments on Earth where water and ice interact. These two important analogs or examples of this process here on Earth are subglacial volcanoes and collapsing ice shelves. And so in a subglacial volcano, essentially what you have is a heat source underneath a thick cover of ice. And what it does is to create localized melt that actually forms a lens-shaped lake just below the surface of the ice. What's interesting about that is that the water kind of sits there and gets to interact with the ice above. In Antarctica, we see great examples of collapsing ice shelves. What these ice shelves do is they sit there for millions of years and then fill up with fractures and then break under their own weight or with help from the water that gets into fractures in those environments. And so with that context, we formulated a model for how Europa might work. So I'm going to show you a little demonstration before I show you an image. So if you imagine that we start off with Europa basically made up of ice that's fractured, but basically just sitting there, and then we add some water. This water comes up from below. It's melting that's caused by a plume of material, much like a mantle plume on the Earth, coming up underneath this brittle ice and filling it up with water. As the lake forms, you actually start to see the icebergs float. You notice that these have been turning around and rotating in the glass. In the case of Europa, there's also a thick material called matrix material that's crushed up ice that sits also on the surface of the water. So you never have liquid water really on the surface, but the water is actually causing the icebergs to float and rotate and to break up the ice around it. What's interesting is that if you were to go back and look at this particular lake on Europa, much later, it would actually be frozen out and maybe resemble something like this, where you've got icebergs and matrix material pushed up, but the entire thing frozen out. And so in the next slide, we have an image of what that process might look like. It's just a cartoon image. On the left, we're showing a collapsing lake with icebergs popped up above the surface and the matrix material starting to fill up with salt-rich water from the lake below. This is the process that breaks up the surface and causes it to look the way we think it does. On the right-hand side, we see a snapshot of this process much later, once the water in the lake is actually frozen out. One of the interesting observations of Europa has been that there are chaos features that are dropped down below the surface and chaos features that are perched up above the surface with these dome-like textures. They always have in common some icebergs or some broken up material, but one's down and one's high. And what this does is to put those in perspective as kind of like a time scale. Drop down means active today with a liquid water lens, and frozen out is popped up above the surface with domes and solid icebergs. And so if you go to the next slide, this is that first image that I showed you of the two chaos terrains. But in fact, in this case, we're showing you the topography overlaid on top of the image. If you look at the image on the left, which is Terra Macula, you'll notice that the center of the feature is depressed down below the surface. In fact, as much as 400 to 800 meters, which means that a giant pocket of liquid water still exists below this body today. What's also interesting is just like in this glass of water, the icebergs are popped up above the surface. If we look on the right image of Connemara chaos, you'll notice that instead the terrain is much lumpier and it's characterized by this reddish color, which means that the surface is popped up and it's filled with water and then frozen. And so on the left, we have an active feature. On the right, we have an older feature that had a lake at one time, but might have already frozen out today. We've also prepared a video for you of how the process might look on Europa. If you notice, there's warm ice down from the bottom, right near the ocean interface, moving its way up, causing warming and causing melting, kind of right in the middle of the ice shell. As that lake starts to form, it brings the surface down because water takes up less volume than the ice it replaces. So the surface collapses down, the icebergs start to float around, break up the ice around it, and then as it refreezes, it's free to dome back up and create the features that we see today that look like Connemara chaos. So this is in fact what we think it might be like on Europa as these features are forming. And to turn back to the Earth example, here is a video of this process happening in Greenland. A very similar process. What you're looking at is Jakobshavn Glacier as icebergs calve from the front of the glacier, turn over, and exist. There you go, big iceberg flipping over and floating around in a matrix of broken up brash ice, which is rich in water, but still really a solid. So this is what it might look like on Europa if we were witnessing it relatively live.
That sounds so awesome. Okay, but still, how could there be liquid water amid all that coldness? Not to mention that far away from the sun. Well, scientists think that this tidal tug and pull energy that we just talked about, this flexing turns into friction and heat. Like when you rub your hands together. Friction and heat. Remember earlier how I mentioned that the other moon, Io, gets mad because I dared go into her room and kiss her and... sorry. Io is so volcanically active, which is thought to be caused by this friction and heat, and on Europa would be warm enough to help maintain liquid water. Here's Robert Pappalardo, Europa Mission Project scientist in 2016.
We know Earth's moon is pretty cold and dead today. So shouldn't Europa have lost all of its internal heat by now, after 4.5 billion years, just like our moon has lost most of its internal heat? There's another source of heating out there that doesn't apply, at least doesn't apply anymore, to our moon. And that's called tidal heating, coming from tidal flexing. Europa, as it orbits Jupiter, gets a little closer and a little farther. The orbit's a little egg-shaped, a little bit eccentric. When Europa is closest to Jupiter, it is stretched out more. And when it's farthest from Jupiter, it contracts a bit. And kind of like bending a paperclip back and forth, that generates heat. It's frictional heat as Europa is flexed. Every time it orbits Jupiter, every 85 hours, every 3.5 Earth days, its ice shell is flexing by about 30 meters. That's the prediction for how much it would flex as it goes around. That'll generate a lot of heat. Some of you may know Io, Europa's neighbor, is the most volcanically active body in the solar system. That's the moon 1in, the Galilean moon 1in from Europa. It flexes something like 100 meters. It's crazy to generate all that heat at Io. Well, a little farther out at Europa, it's not enough to make a super volcanically active body, but it's enough, we think, to maintain a liquid water ocean. We don't know how much of that tidal heat is in the rocky part of Europa. If the tidal heat is just in the ice shell, that's enough to maintain an ocean. But it could be that there's a bunch of heat put into the mantle as well to keep it warm and for there to be volcanoes down on the seafloor of Europa. We don't know yet.
Another reason why scientists are pretty confident that Europa has an ocean of liquid water is that there are fluctuations in Jupiter's magnetic field near Europa. This suggests that there is a conductor of some sort. Scientists feel that there is an electrically conductive fluid, most likely a global salty ocean under Europa's ice layer. Here's Kevin Hand, astrobiologist and planetary scientist in 2014.
Through careful analysis of the gravity perturbations that were experienced by the Galileo spacecraft as it flew by Europa and doing the gravity inversion for the moment of inertia, that leads to an internal mass distribution or internal density distribution for Europa, where we've got an iron or an iron sulfur core, a silicate or rocky mantle, and then an outer layer, a layer of roughly 100 to 200 kilometers, of unit density material. And the simplest explanation for that unit density material is water in either liquid or solid phase. Now, the gravity information is insufficient to reveal the density difference between solid and liquid water. And so the second piece of the puzzle leaves us with this picture of Europa, where we've got a lot of water, but we don't yet have an ocean. To get to the ocean, we need the final piece of the puzzle, and that I like to make the analogy to adhering to airport security. But so what happens when you walk through a metal detector at an airport? What's happening is that you're walking through a time-varying magnetic field. And if you've got a conductor in your pocket, that time-varying magnetic field in that little doorway gives rise to induced electric currents in that conductor in your pocket, and those induced electric currents give rise to an induced magnetic field. And within that little doorway are special detectors that are searching for that induced magnetic field, and the alarm goes off. Well, out at Europa, when the Galileo spacecraft flew by Europa, the alarm essentially went off. Galileo had a fancy compass on board, a magnetometer, and that magnetometer was able to detect an induced magnetic field around Europa. A magnetic field that was not intrinsic to Europa, but which was being caused and mediated by Jupiter's incredibly strong time-varying field. Again, a lot of math that I won't go into tonight, but what this third piece of the puzzle leads to is that you need some near-surface conducting layer, analogous to the conductor in your pocket when you're walking through airport security. You need some conductor in your pocket to create that induced magnetic field. And the best explanation for that induced magnetic field is a salty liquid water layer near the surface of Europa. An iron core, sure, that's conductive, but it's too far away from the spacecraft to explain the induced magnetic field signature. Those rocky silicates, they're not conductive enough to explain that induced magnetic field signature. Ice, even ice doped with salts, still not conductive enough. The best explanation for the induced magnetic field signature is this salty liquid water ocean overlain by an ice shell of a few to maybe 10 or 15 kilometers in thickness.
Another reason scientists conclude that Europa has liquid water is that in 2019, researchers detected water vapor using one of the world's biggest telescopes, the W.M. Keck Observatory in Hawaii. They detected enough water releasing from Europa, about 5,200 pounds or 2,300 kilograms per second, to fill an Olympic-sized swimming pool within minutes. If that's true, whoa. Also, that yellowish color on part of Europa's surface, it's actually sodium chloride, aka table salt, which is also the principal component of sea salt. Since the icy shell is geologically young and features abundant evidence of past geologic activity, it was suspected that whatever salts exist on the surface may come from the ocean below. In a laboratory simulating conditions on Europa at NASA's JPL or Jet Propulsion Laboratory in Pasadena, California, USA, plain white table salt, or sodium chloride, turned a shade of yellow similar to that visible in a geologically young area of Europa known as Terra Regio. Now, the color is significant because scientists can now deduce that the yellow color previously observed on portions of the surface of Europa is actually sodium chloride, or that table salt. The JPL lab experiments matched temperature, pressure, and electron radiation conditions at Europa's surface. So, that is pretty convincing evidence that Europa is the coolest moon. Sorry. I mean that Europa has an ocean of water. In a moment, the biggest reason Europa is a special target for more scientific study and why I am not alone in my fields when it comes to my beloved Europa. Okay, so the biggest reason that Europa is a special target for scientific study is its potential to hold life.
So to sum up the ingredients for life, water, much more than all of the Earth's oceans combined. Essential elements, well, we saw this dark reddish stuff. We don't know if there are organics there. We don't really know the composition yet. We have to find out. Really, we know number one. Number two, well, we have ideas. We don't know. We need to keep exploring and get there and find out. But one would think that from Europa's formation and from later impacts, bringing the right materials to Europa, that it should probably be there. The right elements to build organic molecules, carbon, hydrogen, oxygen, phosphorus, nitrogen, sulfur. Chemical energy is a hard one. So what we're talking about again is could there be enough energy for life down here in the ocean? Because you're not going to get sunlight, you're not going to get photosynthesis going on down beneath 20 kilometers of ice. For that matter, light penetrates, not too far into ice. Well, on Earth, there are lots of organisms that don't care about sunlight. They live off other chemical reactions. These guys don't care about sunlight. They live off the chemical energy from these black smokers on the Earth's ocean floors, places where water has seeped through cracks and pores in the rock and hit places in the rocky interior where warm rock is welling up. And that water gets charged with chemical nutrients, comes back out into the cold water, and those chemical nutrients just condense out. And these critters live very close to such things. So could there be the chemical energy for life at Europa? Well, in Europa's seafloor, there might be very similar chemical energy pouring out of the subsurface. And we've got another source too. The H2O here getting bombarded by radiation, breaking up into H and O, leaving the oxygen behind. If all the oxygen and other oxidants on Europa's surface could be dumped into Europa's ocean would be more oxygenated than Earth's oceans are. So there's the potential for lots of fuel for life at Europa's surface that could if it can get into the ocean. So the circulation of Europa's ice shell, like that convection we talked about, or like melting to form these chaos regions, is really critical. Understanding what's going on inside the ice shell to the idea of whether there could be life at Europa. Can we get those oxidants, the fuel for life, into Europa's ocean?
Once again, that was Robert Pappalardo. So I'm going to go out on a limb here and proclaim as a matter of fact that Europa is an amazing place. Tell me I'm wrong. You can't, because I'm not. But seriously, thing is, I'm not the only person captivated by this fascinating celestial object. Europa has been featured in literary works, like in 1982, Arthur C. Clarke's science fiction novel 2010 Odyssey 2, a somewhat sequel to 2001 A Space Odyssey. Here's a clip from the audiobook narrated by John Stratton. In this section, a Chinese spacecraft had landed on Europa, presumably to refuel using water from Europa. But as things always go in science fiction, they went very wrong. Another ship that is approaching Jupiter with a joint Russian-American crew has picked up a faint transmission from Europa's surface from a Professor Chang. Chang reports the destruction of their ship and the existence of life on Europa. Here is the last part of his message.
The exposed free water bubbled for a few minutes until a scab of protective ice sealed it from the vacuum above. Then I walked back to the ship to see if there was anything to salvage. I don't want to talk about that. I've only 2 requests to make, Doctor. When the taxonomists classify this creature, I hope they'll name it after me. And when the next ship comes home, ask them to take our bones back to China. Jupiter will be cutting us off in a few minutes. I wish I knew whether anyone was receiving me. Anyway, I'll repeat this message when we're in line of sight again. If my suit's life support system lasts that long. This is Professor Zhang on Europa, reporting the destruction of spaceship Tian. We landed beside the Grand Canal and set up our pumps at the edge of the ice.
The signal faded abruptly, came back for a moment, then disappeared, completely below the noise level. Although Leonov listened again on the same frequency, there was no further message from Professor Zhang.
Europa's even in video games, like Call of Duty Infinite Warfare.
Surface temp's 300 below. We gotta move. Reaper, scars and boots on the ground.
Copy 101. Insert is a vertical drop north of your position.
Copy. On the move.
And Destiny 2.
This is what I brought you here to see.
Hollywood has noticed too, like the 2013 science fiction film called Europa Report.
Good morning. We are all very excited to be here today. This really is a new first step for mankind.
It's a found footage film that recounts the fictional story of the first crewed mission to Europa.
Where do we come from? And are we allowed?
Our craft was heading for a moon of Jupiter, known as Europa.
Prep for orbital transfer. We are clear of Jupiter's orbit.
Pitching for power descent. Ladies and gentlemen, hold on. Here we go.
I can't believe I'm here. This is incredible.
Our best hopes of success lies under the ice.
Let's go for a swim. You hear that?
Are you guys seeing this? It's beautiful.
Come back to the ship now.
I want to see if it's reacting to my lights. I'm going to turn them off.
The way in which Europa is visually depicted in these is actually quite stunningly beautiful. The imagination of these authors, of these creators, of the possibilities of what it would be like to actually visit, to step foot on these marvels, is a testament to their power and how small we humans really are. So, when will we make another visit? I mean, Pioneer 10 and 11 did flybys in 1973 and 74, respectively. Voyager 1 and Voyager 2 last flew by in 1979, and now they're looking at our solar system in the rearview mirror. The Galileo spacecraft is gone, which did its job amazingly around Jupiter for almost 8 years, and basically ran out of gas and was purposely flown into Jupiter so as not to crash into Europa and contaminate her. So, as of this moment, the Juno spacecraft is orbiting nearby since 2016, but Juno's mission is focusing on the big guy, Jupiter, which I'm for sure not mad at. So, besides the Hubble Space Telescope and the James Webb Space Telescope giving a look, are we now left to our imaginations or what Hollywood comes up with? Actually, and fortunately, no. NASA is building a mission called Europa Clipper. NASA's Europa Clipper mission will place a spacecraft in orbit around Jupiter in order to perform a detailed investigation of Europa. The mission will send a highly capable, radiation-tolerant spacecraft into a long looping orbit around Jupiter to perform 45 close flybys of the icy moon. So, to help with the study, NASA selected 9 science instruments for the mission, including cameras and spectrometers to produce high-resolution images of Europa's surface and determine its composition. An ice-penetrating radar will determine the thickness of Europa's icy shell and search for subsurface lakes, similar to those beneath Antarctica. It's going to have a magnetometer to determine the depth and salinity of its ocean. A thermal instrument will survey Europa's frozen surface in search of recent eruptions of warmer water at or near the surface, while additional instruments will search for evidence of water and tiny particles in the moon's thin atmosphere. Europa Clipper is set to launch sometime in the 2020s. But NASA isn't the only agency on the planet working on getting to Europa. The European Space Agency, or ESA, is also developing a mission called JUICE, short for Jupiter Icy Moons Explorer. JUICE is the first large-class mission in ESA's Cosmic Vision 2015 to 2025 program. It's going to spend at least 3 years making detailed observations of Jupiter and 3 of its moons, not just Europa, but also Callisto and a special focus on Ganymede. From ESA, Jupiter is the archetype for the giant planets of the solar system and for the numerous giant planets now known to orbit other stars. Moreover, Jupiter's diverse Galilean satellites, 3 of which are believed to harbor internal oceans, are central to understanding the habitability of icy worlds. Understanding the Jovian system and unraveling its history, from its origin to the possible emergence of habitable environments, will give us a better insight into how gas giant planets and their satellites form and evolve. In addition, new light should be shed on the potential for the emergence of life in Jupiter-like exoplanetary systems. JUICE is planned for launch in 2022 and arrival at Jupiter in 2029. You know, I'm kind of glad I came onto the scene late. I get the benefit of looking back on history, the discoveries already made, the data analyzed, because now that I'm paying attention, now I have to wait. I would much rather prefer to binge the info. Man, I wonder how it must feel for all those women and men working so hard on these missions. Going back to Europa in video games, I recently got into this game that's been around forever, but once again, I'm late to the party. It's a space-based game that takes place within the entirety of the Milky Way Galaxy. It's called Elite Dangerous. It's the 34th century. You are a space pilot, a commander of your own vessel or fleet of different ships. This game is massive, an entire recreation of the Milky Way Galaxy, including our solar system. Now, the game doesn't start you out in the Sol system, our solar system. You have to work your way up and earn a permit to travel here. So when I got the game, that was my whole focus. I had to get my permit so I could travel to the Sol system. It was going to be my new home system, and I couldn't wait to take my time and explore, travel to all the points of interest in our solar system. So I did it. I got my permit. I'm here in our solar system. You know, I've been hanging out a lot near Jupiter, and there happens to be a space station near Io, and I've been doing some very lucrative mining out in Jupiter's halo ring. But, you know, it's been about a month now since I got that permit and I've been there, but I still have not gone over to Europa yet. I don't know why. I mean, I'm so close. I could leave this station and be there in a few minutes. I don't know what I'm waiting for. Maybe I'm afraid I'll be disappointed. But that's crazy. I mean, it's not like it's the real thing. Why am I so weird? Anyway, so is Europa the best moon ever created? Well, I happen to think so, at least for now. More wonders are being discovered every day, so who knows what the future will bring to my attention. Like that meme that I mentioned earlier, maybe I'll be looking back at some other moon or planet. With Europa, it's hard to imagine that happening, but you never know. But one thing I do know is that just like the eclipse of 2017,
we are very close to it being the full solar eclipse. This is just unbelievable. What do you think?
Oh, it's awesome. It's amazing. It feels different. We came from Savannah, Georgia, and on this beautiful Navy ship, we're having a great time.
Do you feel a sense of community out here?
Oh, yeah, this is great.
This is really cool. All right, almost, not quite. Oh, look at at that. Isn't that amazing? You can see it without the glasses. Without the glasses. Wow. Look at that. Everybody getting excited now. That's it. Okay, we are in totality, Lester. Everybody excited. And you can actually see a little bit of that. Yeah. Aaron. Oh, yeah. There it is. There's the Corona.
Look at the lights on in Charleston.
There it is. There's the Corona. How do you feel right now? This is incredible, isn't it? It's amazing. A Corona, lightning flashes, and look at all these people. And all these people. How great is this? You're going to tell your kids about this. That is unbelievable. Doctor, as a profession, forget about your profession. How do you feel as a human?
You know, you could think about these things theoretically, but you could know about this theoretically, but when you see it, eyewitness, it's just fantastic, right? And to have the energy of all these people that you have around us.
This is the effect nature can have on we humans when we pay even a little attention to it. And when I gaze into the wonders of the night sky, I'm filled with appreciation and thankfulness that they are there. And I feel loved.
I'd like to close with one of my favorite images from the history of space exploration. It's an image carved by none other than Galileo Galilei, some 400 years ago. Galileo turned his telescope to the night sky and carefully charted Jupiter, and he noticed these 4 tiny little specks of light around Jupiter. Now, of course, in the early days of his charting these little points of light, he initially thought that they were stars, but he soon realized that these stars were moving. And night after night, he charted them and determined that, in fact, those 4 little dots were not stars, they were moons. They were moons of Jupiter. And if Jupiter had moons, then it must be similar to the Earth, because, of course, Earth had been, up until that point, the only world that had a moon. And so if things were going around Jupiter, then that went against that Aristotelian view of the Earth being the center around which everything else revolved. And in the decades that would follow Galileo, we would come to learn and appreciate that the laws of physics apply not just here on Earth, but also to these worlds and wonders beyond the Earth. And in the decades and centuries after that, with the advent of spectroscopy and new techniques for studying stars and planets, we would come to appreciate that the principles of chemistry apply not just here on Earth, but also on worlds and wonders beyond the Earth. And then with the advent of our robotic exploration of the solar system and our investigation of worlds like Mars and Mercury and Venus, we would come to appreciate that the principles of geology apply not just here on Earth, but also to these worlds and wonders beyond Earth. But when it comes to this bizarre little thing we call life, when it comes to the phenomenon of life, when it comes to the science of biology, we have yet to make that leap. We don't yet know whether or not biology works on worlds and wonders beyond Earth. We have every reason to believe that it should. Our study of life on Earth leads us to think that life is likely everywhere where the conditions are right. But we have yet to do that experiment. And part of what excites me about the time in which we live, part of what excites me about the next few decades, is that for the first time in the history of humanity, we have the tools and technology to answer this age-old question of whether or not we are, in fact, alone in the universe. And so I hope that some 400 years from now, our descendants we'll be able to look back at this time in much the same way that we can look back at the revolution that Galileo's work began. Our descendants, some 400 years from now, will be able to look back at this time in the history of human exploration and scientific discovery. Not just this time, this place. JPL, a premier place in helping to achieve the exploration and the science that needs to be done to advance these kind of discoveries. I hope our descendants will be able to look back at this time and this place and say, it was then, it was there, it was through the perseverance and the exploration that the discoveries were made that brought the universe to life. Thank you very much.
Once again, that was Kevin Hand, astrobiologist and planetary scientist, in 2014. And before that, coverage from NBC News. I hope listening to this has inspired you to check out these marvels in more detail. Google them. Do you see what I see? Do you agree? I'd love to know. My email is studio@sonicembassy.com. And you can also find the Sonic Embassy on Twitter, Facebook, and Instagram. Some great resources other than your favorite search engine are 9planets.org, Europa.nasa.gov, solarsystem.nasa.gov, jw.org, and psi.esa.int/juice. Our website is sonicembassy.com. If you enjoyed this episode, the best way to show it is to tell others about it. And if you hated it and you're still listening at this moment, well, you know what? The best way to really stick it to me is to tell others about how much you hated it. Like, guys, y'all got to check out this horrible podcast. Here, listen to it. That'd really get me. You should do that. If you have an idea that you think would make a great episode, by all means, let me know. Thank you so much for listening. I love you, and I hope you'll listen more soon.
Embajada de Sonic.
Sonic Embassy.